Alrighty, welcome to your pre-lesson video of week 1.2 where we will be covering fractions. So let's get started. So you're probably wondering, what are multiples? So multiple is a whole number that results from the product of two other whole numbers. So for example, right, let's take 7. So the multiples of 7 are, if you do 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 2 is 28, and so on. So it can be for any numbers. It can be like 5 times 1. So like multiples of 5 are like 5, 10, 15, 20, 25, 30, 35, and so on. Right? And just remember that every whole number is a multiple of itself. For example, like 24 is a multiple of 24. 50 is a multiple of 50. All right. And then the next thing we have are factors. So a factor is a whole number that results from dividing two other whole numbers. For example, right? So for the factors of, let's take 30. So the factors are like 1 times 30 is 30. 2 times 15 is 30. 3 times 10, there we go, is 30. And lastly, 5 and 6 are 30. Oops, that is supposed to be a comma. Give me a second. There we go. Right? And so that means our factors of 30, if we were to rearrange it in ascending order, is 1, 2, 3, 5, 6, 10, 15, and 30. So that means these are the factors of 30, right? So again, a factor is a whole number that results from dividing two other whole numbers. And we'll get to practice that a little bit more in your homework also. And remember, 1 is a factor of every whole number, and every whole number is a factor of itself. For example, like factors of 52 include like 1 and 52 besides the others. Now on to the next thing, prime numbers. So a prime number is a whole number that has exactly two factors only, 1 and itself, right? So that means it cannot be divided by any other number. Now if you've noticed with prime numbers, 2 is the only even number that is a prime number, because any other even numbers like 4, 6, 1000, 2000, those can all be divided by 2. So that's why they're not prime numbers, right? So for another example like prime numbers, let's take the number 13, right? 13 is a prime number because its factors are only 1 and 13. It cannot be divided by any other number, all right? And let's see, 1 and 0 are not prime numbers. We do not consider 1 and 0 to be prime numbers. All right. Now, the next thing that we have are composite numbers, right? So composite number is essentially the opposite of a prime number. So it is a whole number that isn't prime, right? So it has more than two factors. For example, let's take 12, right? Because 12 is considered a composite number because it has factors 1, 2, 3, 4, 6, and 12, right? So it has more than two factors, and that's why it's considered a composite number. Now the next thing we have is prime factorization. So prime factorization is factoring a composite number to its primes, right? So it will also include duplicates. So let's take the example of 48, right? So if we break it down to its primes, it is 2 times 2 times 2 times 2 times 3, right? So that means its prime factors are 2 and 3. See how I only wrote 2 once? Because it will include a duplicate. So that means when we break down prime factorization of a composite number, right, we'll write it as 2 times 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 3. That was a mouthful. All right. And then when we list the prime factors, we will just mention the things that are duplicated once. So like the prime factors of 48 are 2 and 3. Does that make sense? All right. If you have any questions about like prime factorization, bring that up during our deep dive lesson. Right, and then the next thing that we have are reciprocals. Right, so very basic first thing first is like fraction is a numerical quantity that's not a whole number. So we write it as like 5/8. Let's take for example, right? And so the reciprocal of 5/8, so reciprocal means it's the switching of like its numerator and denominator. You're just flipping it. So that means the reciprocal of 5/8 is going to be 8/5. Does that make sense? So you're just literally flipping the numbers with each other, top and bottom. Okay. And then the next thing we have is least common multiple. So the least common multiple is we're finding the multiples that is the least between two numbers. So let's take 6 and 8. So one way to find that out is to list all of the multiples, right? So let's go 6, 12, 18, 24, let's see, 30, 36, 42, 48, 54, 60, and then let's do our multiples of 8. So we'll have 8, 16, 24, 32, 40, 48, 56, 64, and then 72, and then 80, right? Now, if we look here, oh look, 24, that would be our lowest common multiple between 6 and 8, because yes, there is also 48, right? But 24 comes first. That means that 24 is our least common multiple between 6 and 8. Does that make sense? If you have any questions about that, bring it up again during our deep dive lesson. All right. And now let's look. Greatest common factor. So greatest common factor is the biggest factor that we have between two numbers. So let's take the number, let's go with 36 and 45, right? So now we're going to break this up into factors. And so we know the factors of 36 are going to be like 1, 2, 3, 4, 6, 8, let's see, and then 12, and then 36. Let me see if I get everything. 1 times 2, 2 times, and we are also actually missing, hold on. Let's see, after 12 is 18, and then 36. There we go. All right. So now let's break it down for 45, all of its factors. So we have 1, 3, 5, 9, 15, and 45. Right? I just realized. Hold on. This would not be 8. My bad. I had meant to write 9 there. There we go. All right. So now as we look, we have broken down these two numbers into their into their factors, right? So now we want to look at which one is the biggest. So we look, 9, right? So 9 will be the greatest common factor between 36 and 45, right? Because that's the biggest factor that they have. There's also 3, but it is smaller than 9. Okay, so that means 9 is our greatest common factor for 36 and 45. If you have any questions about this, bring it down during our deep dive lesson. All right, now on to the next thing. So equivalent fractions are essentially the reverse of simplifying of fractions. So equivalent fractions, you want to, in order to find them, you can do like 2 times 2, and then 3 times 2, which would give you 4 over 6. We'll do the same thing like 2 times 3, 3 times 3, and that will give you 6 over 9. And we'll do like 2 times 4, 3 times 4, and that will give you 8 over 12. And obviously, as you can look, all these are equivalent fractions because when we simplify them, they will all give us 2 over 3. And that's how you would find equivalent fractions, right? Now, for reducing fractions to the lowest term, or essentially simplifying fractions, it will be the opposite of doing equivalent fractions. So what you want to do is find their greatest common. You could either just slowly do it multiple times, or you could straight away find their greatest common factor, right? So let's do here. Let's do 125 divided by 25. And let's do 750 divided by 25. And that is going to give us, let's see. And that is going to give us 5 over 30. And look, these can still be simplified even further. So we know that these two numbers can both be divided by 5, right? So we're going to do that. So then we're going to get 1 over 6, right? So that means 125 over 750, when you simplify it, will give you 1 over 6. Does that make sense? All right, now the next thing that we have is improper fractions to mixed numbers and vice versa. So in order to make this is what we call an improper fraction. In order to make it into a mixed number, what we would need to do is have division. So we'll take the bottom number, put it outside 6 and 98, and we'll do division. So how many times what? 6 times what equal will we have the multiple closest to 9? So it's 1, right? So we'll go 6, 3, drop down the 8. So now we have 38. And then we know the closest, well, let's write that one. Closest multiple of 6 to 38 is 36. So 6 times 6 is 36, right? So minus 36 will give us 2. Now if you look here, we're going to take this top number and it is going to become what I call the big number, right, of the mixed fraction. And then the remainder that we have is going to become our numerator. And then we're going to take 6 because we divided by that. And look, we can still simplify this further, right? So, and we know that 2 and 6 can both be divided by 3, so that will give us 16 and 1/3. And that's how you change an improper fraction to a mixed number. Right, now the opposite. Let's draw a little line there. There we go. So in order to find the mixed number into improper fraction, what you would need to do is these 2 times and these ones once. So essentially it's going to look like this. Everything's still going to be over 11. Right, so you're going to do 4 times 11 plus 5, and that's how you will get an improper fraction. So you want to take the big number, multiply with the denominator, and then from there you want to add it to the numerator, and then that will give us, let's see, it will give us 49 over 11, and that's our improper fraction. All right, now with adding and subtracting fractions, the first thing that you need to do is make sure that they have a lowest common denominator. So it's essentially the same thing as finding the lowest common multiple, but you're just finding it for the denominator. But it's the same concept, right? So we know for a fact that the lowest common multiple between 13 and 5 is going to be 65, right? So that means I'm going to do 9 times 5, which is 45 over 65 plus, we're going to add a negative number, right? Ooh, so let's see. So 4 times 13 is 52. That's going to give us 52 over 65. And now, again, with PEMDAS, right? After right, we're going to add, but we're adding a negative number. And we know that 52 over 65 is going to be a bigger number. So that means 45 over 65 plus negative 52 over 65 is going to give us negative 7 over 65. And we know that this is the final answer because we cannot simplify it. All right. And now for our last thing, multiplying and dividing fractions. So with multiplying fractions, let's look here. I'm just going to write this out so you can clearly see. So with multiplying and dividing fractions, you want to be able to simplify it first because that will make your life a lot simpler because you will be dealing with smaller numbers, right, rather than multiplying bigger numbers. So let's look. We know that, so when you are looking at it, you want to do it as across. All right, so if we look, 2 and 8, a common thing that these two numbers have is they both can be divided by 2. So 2 divided by 2 becomes 1, and 8 divided by 2 becomes 4. All right, and now let's look at 3 and 9. We know that these two numbers can both be divided by 3. So 3 divided by 3 is 1, and 9 divided by 3 is 3. Right, and now once we have simplified everything, we can multiply them with the number that's across. Right, so then that's going to give us as 1 times 3 over 1 times 4, which would then finally give us 3 over 4, and that will be the answer. Does that make sense? If you have any questions about this, bring it to the deep dive lesson. All right, now we look at division, right? So first thing with division, essentially you want to flip the number that's on the fraction that's on the right. Okay, so if we were to flip it, once we flip it, we're going to put a times sign. And by flip it, I mean the reciprocal, right? So as you can see, 2 over 5 has been flipped to 5 over 2, and the divide sign has been changed to a times sign. Now from here, you can again simplify as needed. So we know 5 and 25 can both be divided by 5, right? So I'm just going to straight away do that. That will give us 11 times 1 over 5 times 2. Finally, that's going to give us 11 over 10. All right, so you can either leave this as an improper fraction, which is what they would recommend during your tests when you are bubbling it in, or if you want to for your homework, you can also leave it as a mixed number, which will be 1 and 1 over 10. All right. And so remember, with fractions, same thing, you want to use PEMDAS for your order of operation. So remember, parentheses, exponent together, multiply, dividing together, addition, subtraction together, left to right. All right, any questions? As usual, bring it to your deep dive lesson. Have a good rest of your day.